In this lesson, I want to discuss the fact that vertical motion has symmetrical aspects to it. So imagine an object that's launched upward with a speed of 25 meters per second. What happens to the object's speed as it moves through its path? So we're going to begin with a speed of 25 meters per second, and that's going to be right here at the bottom on the ground level. Let's draw a line, horizontal line here at the 5 meter mark. So this is 5 meters. At 5 meters, if we use Vf squared is equal to Vi squared plus 2ax. So at the 5 meter mark, we know a is negative 9.8, and we know that the initial speed is positive 25 meters per second. We can calculate the final velocity. And what we find is that the final velocity calculates to be 23 meters per second. So at 5 meters per second, Vf is equal to 23 meters per second. Okay, so right here. But if you notice that at 5 meters, the object also comes back down to the 5 meters marks in this particular direction. So on the upward swing, we're at 23 meters per second. On the downward swing, we are at negative 23 meters per second. So it's plus or minus 23 meters per second. The way we get that is final velocity is equal to the initial velocity, 25 squared, plus 2 times negative 9.8 times 5 meters. And final velocity, remember, it's going to be equal to the square of whatever this number is here. Let me do that on a calculator. So we have this right here is going to be 625. So 2 times 9.8 times 5, and this is 98. So it would be 625 minus 98, 527. So this would be the square root of 527. So Vf is going to be equal to the square root of that, and that's 22.95. I'm calling that 23, but it's plus or minus 23 meters per second because there is an up and down component because of symmetry. So you can test that calculation and these others. So let's look at what happens at the 10 meter mark. At the 10 meter mark, using the initial speed of 25 meters per second and using this same calculation, we find out that the upward speed is positive 21 meters per second, and then the downward speed here, when you're coming back down, is going to be negative 21 meters per second. For the same reason, we're going to take the square root of that product or that combination of numbers, and that's going to give us a positive and negative answer. If we go up higher, let's see, to this level right here, let's make that the 25 meter mark. 25 meter mark. Well, on the upswing, that calculates to 11.6. I calculated this previously. 11.6 meters per second, and on a downswing it's going to be negative 11.6 meters per second. Okay, so we know that the velocity is going to decrease as you go up until you get to the apogee, maximum height, where here, of course, the velocity is going to be instantaneously zero. And then from this part right here, you'll have a negative velocity ever increasing. So what would be the velocity upon striking the ground? Well, what we can do is use the same equation. Final velocity is equal to the initial velocity plus 2ax. Hitting the ground means that delta x is equal to 0. So you start on the ground and you end on the ground. The displacement is going to be equal to 0. So Vf squared is going to be equal to Vi squared plus 0. which means the final velocity is going to be equal to the square root of the initial velocity squared. And the square root of a square is going to be equal to plus or minus vi. Okay, so whatever goes up is going to come down with the same speed.